Hi, good morning, everyone. I welcome you all for one more session of chemistry. During the last class, we have just discussed about P and N type of semiconductors, right? So, P and N type of semiconductor in briefly, right? So we have discussed about that. About their definitions and what is N and P, right? So N is nothing but what I said, negative type of semiconductor. Negative. That means in these type of semiconductors, the negative character is more. One we can say, right. So the electron rich center one we can say, right. So negatives type, N type, and one more we saw that is P type of semiconductors, right. So today I will just give you idea once more, once again about the N and P, and then we see one more extra character about this, and then directly we will move towards the magnetic properties of solids, right? So see here once again, here the first of all the host was 14th group element, right? So the owner of that particular matter is what? 14th group element. That means host. To that host, what we did, we have added impurity of 15th group element arsenic, right? Plus 5, and it was silicon with 4 charge. That means, see, actually our silicon require only 4 bond around it, but what we are giving 5 bonded compound. So that means one extra electron will be remained in the particular solid. Yesterday, in the yesterday's class, I have shown you with the diagram, right? So one extra electron will be released or remain as it is. So that's why what happens over here is, alright, what happens is nothing but the x, because of the extra electron, that particular matter will be after this arsenic adding up the impurity like arsenic, the complete solid becomes a negative dominant character matter, right? So that's why the type we what we call is N type of semiconductor. Is it clear? So now what happens when we add the extra electron to the density is nothing but here increase in the conductivity increases one point, and then what happens, see, we require only 4 around each and every silicon, but what we are doing, we have added extra electron. That means the number of electrons are increased. So if the number of electron increases, then definitely the density in N type, what happens, definitely increases. Very important, right? The density here in case of N type of semiconductor, it will it will be increases. Why? Because clearly one we can see here, right? So why one extra electron we are adding into the host cell or host matter. So that's why what is happening is the total matter is becoming a negative character. So thus the one electron, because of adding a one electron, the conductivity definitely increases. Not only the conductivity increases, the density will also goes on increases. Why? Because we have added one extra electron over here in this type, N type of semiconductor. So now coming to P type, so this is the extra character I am discussing, right, about P and N type. So P type is nothing but, again you know very well, P type is nothing but positive charged, right? Here also we took same example of 14 group as a host. To that host we have added a impurity of 30th group, and for this also we take same example, and here in 13th group, aluminium is the best example. It can We can add this aluminium for a host as an impurity. So if I add this into the host of 14th group, then definitely We require 4 bond around the each silicon. After adding aluminium, they are having a scarcity of electron, right? So one vacant part will be remained like this, right? If I show just one example, then you can very easily understand this. Silicon and silicon, right? So this aluminium will not form a bond exactly not only with this silicon, or it may not form a bond with any one silicon, right? Why? Because it can donate only 3 electrons. So that's why I have donated the electron of aluminium for this silicon, and this silicon. What about this, right? Here the problem comes. So that's why one vacant place will be remained in case of what? 14 group elements. So that means what happens to the density here? Definitely one we need to add 4 in actual, but what we are doing, we are adding just a 3 valency element. So definitely clearly when we can see the density, definitely here what happens, decreases. Why? Because we have lost one electron. So because of this, we are getting a vacant place in the solid because of impurity, like a lower group impurity. If we add to the higher group, then definitely the type that is called P type of semiconductor will be arises. So this is all about P and N type of semiconductors. Definitely, I will send the notes in your group, so please go through it, utilize these holidays time, right? And make a proper notes. So it will be very easy for you. Whatever I taught in the class, it will be easy for you. Otherwise, if you don't have any notes, then definitely you will not go for reading book. I'm sure about that, right? So please, I will send the notes, right? So you in your particular group, right? So take those notes and try it. I will not give a printed notes. Why? Because already I have given all the concepts of this chapter. Just last part is remained, right? So that's why I will just written notes I will send you. So take it. When I start new chapter, definitely I will send you my own printed notes itself, right? Right. So next thing is in your syllabus, that is magnetic properties in solids. So this magnetic property in solids is very important. Magnetic properties in solids. So first of all, I will remind you that always whenever there is an electron present, there will be a motion. Definitely the electron will not be stationary, always it will be in the motion, right? If it is in the motion, definitely the magnetic property will come. If there is no electron, then there is no question of what? Magnetic property, right? So till now what we studied about the magnetic property is nothing but diamagnetic as well as the paramagnetic in case of organic chemistry, inorganic chemistry, right? So in the last year, so dia means completely filled, right? If the orbitals are paired up, completely paired up, then those are called as what? Diamagnetic type of substances. If the orbitals are not paired up, I mean half filled, then definitely those type of orbitals or the elements are called as what? Or substances are called as paramagnetic substances. And even during offline classes, also I have explained in the inorganic chemistry of coordination compounds, right? Right, and as well as in case of D and F block also, right? But here in the physical chemistry, we see that different definition of these magnetic property, and nearly we see 5 magnetic properties. And dear students, one thing it is very important in this solid state, last part of the solid state is, among these 5 type of magnetic property, one will be fixed in your exam, right? Very important. So with its example, right? You have to write the definition as well as its example. There are 5 magnetic properties, and those are, I will just say, paramagnetic, diamagnetic, ferrimagnetic, ferromagnetic, and antiferromagnetic, right? So there are 5, and those are paramagnetic, diamagnetic, ferromagnetic, ferrimagnetic, and antiferromagnetic, right? So we will go one by one. First one we will see in case of number one property, that is paramagnetic. So paramagnetic substances. So for you people, you need to write what is paramagnetism, and then you have to give one example, then only you can get 2 marks in this part, right? So we know in the physical part, what we say, the magnetic property we can observe by taking a magnetic field, right? So there will be an south pole, north pole, right? You are very well aware about this, right? In physics, generally you have this part very importantly, right? So whenever, if a substance, we don't know about the substance, if we bring any substance, right, towards the magnetic field, if they are weakly attracted by the magnetic field, weakly, that means not strongly attracted, if they are weakly attracted by this magnetic field, very important, right, weakly attracted by this magnetic field, then such substances are called as paramagnetic substances. Weakly attracted, right, weakly attracted by the what? Magnetic field. Whenever we bring any substance, we don't know the magnetic property of that. If we bring near to it, if they are weakly attracted, then definitely such substances are called as what? Paramagnetic substances. And examples are, you go through the books, you will find more examples. I will give just important and easiest examples. So for paramagnetic, O2 is best example, air, right? And Fe3, Fe plus 3, Fe plus 3, or Cu plus 2 copper, Cu plus 2. So these are the best example for what? Paramagnetic substances. So paramagnetic substances are those substances which are weakly attracted by what? Magnetic field. Such substances are called as paramagnetic substances. And for those paramagnetic substances, the best examples are oxygen, iron, which is in plus 3 form, right? Copper plus 2, right? Iron, copper, and the oxygen. You will get more number of examples. Please go through the book, right? So next, this is about first type of magnetic property, that is paramagnetic substances. Next, we'll see number 2 property, that is diamagnetic substances. Diamagnetic substances. So again, again you take the same thing, that means a magnetic field, north pole and south pole, right? So if any substance, if we bring near to this, magnetic field, if they are weakly repelled, right? If I bring any substance with no magnetic property, we don't know about the magnetic property of a simple substance like NaCl, best example for diamagnetic. If I bring the NaCl near to this magnetic field, then if the substances are weakly repelled, if the substances are weakly repelled by the magnetic field, then such substances are called as diamagnetic substances. And for diamagnetic, we all know very easily that is NaCl or table salt is the best example. And one more thing, that is water molecule. So these two examples, one we can remember very easily. Why? Because daily we use these element, I mean compounds, right? So diamagnetic substances are those, if they are weakly repelled by the magnetic field, then such examples are such substances are called as what? Diamagnetic substances, right? And the examples are very easy. That is table salt as well as the drinking water. One we can say. So these are the two best examples for what? Diamagnetic substances. So for today's class, we will conclude with this. And in the tomorrow's class, we will discuss about those still three more type of magnetic property. And then later, I will take you to the some conductor, semiconductor, insulator, and the band theory. Right? So with this, we will conclude this. In the next class, we will try to wind up this chapter. Right?